just a fancy name for depositing material, deposition. Deposition aggregation is going to occur when the velocity and the capacity and the capability, which is the discharge of, or the product of the discharge of the river, starts to diminish. If I lose the capacity of the river and the capability of the river, stuff is going to fall out. So I lose a little bit of that. The biggest stuff is going to then stop moving in the river. I lose a little bit more. The next biggest stuff is going to no longer move in the river. I lose a little bit more. The next biggest stuff is going to start to be deposited out of the river. So basically, as soon as the river has more material than it can carry, things are also going to fall out. So it's sort of like the camel's back that gets broken with one more straw. The camel can keep moving and doing its thing, but you add one more piece of something to the saddlebags and the capacity is reached and things start to fall out of that river. Generally speaking, when the velocity of the river diminishes is when we're going to exceed the ability for it to transport material. All right. So we can see this happening in a couple of different places across channel characteristics. In this image, if you take a look, I've got what appears to be a very wide river up here, and it's draining a mountain environment where I've got thousands and thousands of tiny little streams. They all come together and they feed into this flat area. And this flat area, the material which was eroded out here gets deposited down here. And because the deposition area is so broad and we've changed velocity, we can't carry that material anymore, so it falls out and creates this type of shape. This braided stream starts to happen. And if you look really close, you can see where the stream used to run. So I've got this old scar right here, or an old scar here. And then I've got really old scars. These scars actually still have some water in them over here. So what happens is as the river is moving and as it's becoming slower, it's going to deposit some material. That material then becomes an obstacle for the river to flow or over it, so it begins to flow around it. And as the water flows around it, it's still depositing material. And eventually it deposits so much material that the water changes direction again, it changes course. And consequently, what ends up happening is the river creates many, many different channels, which is what you're seeing here. There's not one channel here, there are hundreds of channels through here, and the channels are constantly changing where their locations are. They're being created, they're being destroyed, they're shifting, and the volume of shifting then depends upon how much discharge there is. If there's a lot of discharge, then there's not so much shifting. If there's a little discharge, then we're depositing more material, so there's going to be more shifting in the stream. So we get this lovely braided channel that's produced. We get aggregation this way as well at the mouth of rivers. So this is a delta which is being formed, and they're generally fan shaped. So here's the top of the fan out here, and then here's the base of the fan, and the mouth of the river is here. With very large rivers, the mouths are not entirely open. You get island formations being produced, and these islands that are being produced is material which was aggregated, deposited in the past. All right, so in this case, this is a river that is located at the equator and in Brazil and depositing into the Atlantic Ocean. Now, this Atlantic Ocean is this blue color, this blue-green color out here. All of this taupey sandy color is the suspended load and the bed load that is still being transported out into this river. So out here where the channel is still moving quite fast, we're moving everything. And we can tell where the velocity and the capacity of the river slows down because we can see from the satellite image the color change in the deposited material. So out here it's pretty dark, so we're carrying a lot of stuff, but by the time we get past these little islands that have been of deposition that have been created, the taupe color diminishes, which means we've lost some stuff, right? So right here, we're still moving pretty fast near the mouth of the river. We're still carrying a lot of stuff. As we move further out into the delta, I've lost a lot of stuff, but I'm still carrying a good bit of material. But increasingly, I'm able to carry less and less stuff. The velocity of the river is diminishing as I move out towards the edge, where I finally lose the smallest and last bits of the river's once bed load and suspended load way out here. Now, channels have some important characteristics to them in terms of their velocity in the river. So for the most part, we had introduced a little bit ago a term called roughness or roughness coefficient. At the contact point where the water meets the shape of the geology, the bed, here's the bottom and then the sides of the river, the roughness is the greatest. And at those locations, the velocity is going to be the slowest. As you move further and further away from the edge, the velocity increases. So here I've got a velocity of 0.05 meters per second. As I move higher away from the bottom of the river, my velocity increases to 1 meter per second, or 0.1 meters per second, and then 0.2 meters per second. Or if you will, 2 feet per second in sort of this zone right here. Where the volume is deepest and furthest away from an edge is where the greatest velocity is going to occur. So think of this as the place where we're going to move the most material, right in this location here. All right. So looking at this again, this is going to be high velocity, zone of transportation. We're going to move the most stuff here. Lower velocity down here, we're going to move stuff, but we're not going to move it very effectively. This is going to be more likely where we're going to deposit material. In the end, what we end up getting is zones along a river where we've got deposition zones and erosion zones. Now, erosion is going to be where the velocity is moving the fastest. So it's going to be where the water is the deepest. And in that case, it's where we've got something called a cut bank. So along this cross section here, this is this edge which is shallow. You can see from this illustration that we've got sort of a little beachhead. On this side, we've got a deep wall, and the highest velocity is occurring right here. Across this cross section, I have a pretty even little river here, which means my velocity is greatest right in the middle of the channel. So if you are a kayaker or a canoeer, you're looking to move your vessel towards the edge where the velocity is the greatest. We come through here, the velocity is the greatest. We come through here, the velocity is the greatest. All right, so we have to read the banks to know where the velocity is going to move us down the channel. So this last area right here is this cross section. Here's the cut bank where erosion is taking place. Here's where my velocity is the best. Here I'm shallow. That's this end here. That's where this deposition happening. So those characteristics are considered meanders. They're nice gentle beds. The outside of the bed is where we're going to get that fastest velocity. It's going to have the greatest erosion potential, and you're going to have a nice steep bank. These are called cut banks. The inside of the bend, the narrow part where it bends the most, is our point bars. The velocity is slow there, and that's where we're going to get deposition. Out of this, we can get some pretty neat little things called oxbow lakes. And what has happened is an oxbow lake is where there used to be a bend in the river, but that part of the river got abandoned because of erosional forces and depositional forces, and the river took a different channel at some point, leaving behind a oxbow or a C-shaped lake. So here is an authentic image of a point bar and cut banks. So remember we said point bars are the narrow inside bend. So you can see the sand being built up right here on this inside of the bend. And again, here's an inside of the bend where we've got sediment being deposited. This is the slow part of the river. Here's the outside of the bend. This is where the velocity is the greatest. So we're going to have the deepest channels here. And this is where we're going to erode on the deep side. Here's the outside of the bend, which is the deep side, where we're going to then erode material. Illustratively, with these cut banks, we can develop this oxbow lake. So sequentially, 1, 2, 3, 4, we've got this nice bend in the river over time, and we can see I've got a cut bank and a cut bank happening back to back from each other. And eventually this is going to remove material and meet up with this side. So let's watch that happen. So here's the river going along its channel over time, depositing and eroding material. And in doing so, we're cutting this material away and cutting this material away, and we're creating maybe different shapes in the river. Eventually, that cutting this material away causes the river to join, and no longer does it take this path through here. It takes a little shortcut. It sort of skips through here, and as it's skipping through here, it starts to deposit material on this point bar right here. And when it does so, it starts to silt in material, and because it silts in material, the new channel appears right here, and it leaves this C-shaped oxbow lake behind. All right, I'm going to drop in some pictures or some videos into the module so you can see this from the Mississippi. Here is a oxbow lake that is being created. So you can see where the river used to occur, and to some degree still does, but over time we're going to close this channel off, and this is going to be an abandoned part of the channel and an oxbow lake. With that, we can look at this rather old satellite image, but I like it because it's really easy to see some of these oxbow lakes. So everywhere where there was an oxbow, we've got a little oxbow here, I've got an oxbow here, even out here. In fact, look, we can see the really old channel that used to be through here that's now abandoned. So we sort of had this funky snake-like lake that was created across this landscape. In fact, I've got this Yazoo stream out here, and yeah, Yazoo is a real name. I didn't make that one up. All right, so here is some evidence of abandoned stream channels that have been created to make oxbow lakes.